Hello there once again. In this lesson we learned about geometric series or geometric sequences. In the core 1 specification, or in the core 1 module, you probably would have learned about the arithmetic series. An arithmetic series is basically a sequence of numbers where the difference between one number and another number is an addition of a number. So let's look at a sequence. So 2, 5, 8, 11. So difference between 2 and 5 is a 3. Difference between 5 and 8 is a 3 as well. So difference between 8 and 11 is also 3. And this is called an arithmetic series or sequence. Whereas a geometric sequence, the difference between one number and another number is a multiplication of a number. So from 2 to 4 you multiply by 2. So 4 to 8 you multiply by 2 as well. And 8 to 16 you multiply by 2. So that is a geometric sequence. Okay, so that's an arithmetic sequence and that's a geometric sequence. Right, now we're going to look at the notation that we used when we describe a geometric sequence. The notation that we used. Okay, now let's look at this sequence here. Okay, let me choose a different sequence because I don't want you to get confused between this two and this two here. Let me start off with a 3, and then I'll say that's a 6, and then say that's 12, and let's then say that's 24. So you can see you start off with a 3, then that's multiplied by a 2, that becomes a 6, multiplied by a 2, that becomes a 12, multiply that by a 2, and that becomes 24. Alright, so the first term in this sequence, so this sequence is going to go on and on. The first term in this sequence is 3, and the notation that we use is A. So the first term of a sequence, you use the notation A. And between each term, it's not a difference, but it's a ratio. So the common ratio, so that's this number that you multiply each term by, each subsequent term by, which is 2. So the common ratio is denoted using an R, is 2. Alright, so if I were to write this sequence using these notations only, the first term is the first term, so it's just A. The second term is the multiplication of the common ratio times the first term, so that's A times R. And the third term is the multiplication of this times another common ratio, so that's A times R times an R. And the fourth term is 8R times an R times an R, because this was multiplied again by another 2. But this is rather a long-winded way of writing our notations. It's better to use indices. So it's A and AR, and then AR squared and AR to the power of 3. Okay, so the first term is always A, the second term is A times R. Okay, so if I gave you a geometric sequence and if I said to you what the first term was, so in this case let's say the first term was equal to 5 and the common ratio was equal to 3, and if I wanted to know the first term, that'll be 5, the second term will be A times R, so that's 15, and then the third term would be A times R, which is 9 times 5, which is 45. Okay, and you can work out the rest of the terms of that sequence. What if I asked you for the 11th term? Okay, so you can see that the first term has just A, and the second term has just AR, and the third term has AR squared. So there's always one difference for this power of R between the term that you want and the power of R. So if I say I want the 11th term, then that means you got to say A r to the power of 10. Alright, so let me see if I can work that out. That's 5 times 3 to the power of 10. The answer to that is this. Okay, now that's a rather big number, but you could imagine that because you multiply 3 10 times over and then multiply that by 5. Alright, so that's the answer to that. So if I were to develop a generic way to figure out a particular term of a geometric sequence, it would be a times r and n minus 1. Okay, now don't get too much put off by these symbols. N stands for the term for which you're trying to figure out the term of that geometric sequence. So in this instance, it was the 11th term that you were trying to figure out, so n would have stood for 11. Okay, minus 1 is because you always take out a 1 from the power to which you raise the ratio, because that's how it works, doesn't it? Because if you're working out the second term, it's always r to the power of 2. Alright, so if you want to work out the 11th term, it's r to the power of 10. So that's why you do n minus 1, and that's the power to which you raise the common ratio, and you all obviously time it by the first term. So that's the generic equation to figure out a certain term of a geometric sequence. Alright, so let me quickly give you another example to see whether you could work this one out. So the first term is equal to 4 this time, and the common ratio is equal to 5. So could you work out for me the fourth term, please? Alright, I'll give you a moment. Just pause this and then let me know the answer. Let's see what the answer is. So that's a r, so that I want the fourth term, so that's 4 minus 1, and then therefore a is 4, r is 5 to the power of 3. So that is equal to 4 times 125. 5 to the power of 3 is 125, and that is equal to 500. Now that's the answer. Brilliant. Okay, now we'll look at something else. Just as in with the arithmetic series or the arithmetic sequence, you would try to find the sum of terms up to a certain term of an arithmetic sequence. So you would say 2, 5, 8, 11. So this sequence will go on. So let's say if I want to know what's the sum of the first 4 terms. Well, the first 4 terms, sum of the first 4 terms. Okay, that's easy enough. You could just count these. But what if I said I wanted the sum of the first 44 terms? Now you can't go on adding one number to another. That's a rather tedious process. Same with the geometric sequence. So let me write out another geometric sequence. I'd say 4, 12, 24, 72. So each term is multiplied by, nope, I have not done that right. Each term is multiplied by 3. So therefore it's not 24. Let me just blacken that out. It's not 24, it's 36. So it's 36 in fact. So 12, 36. Okay, and so forth. Alright, so even with this geometric sequence, if I said I wanted the first 8 terms, now you're going to have a hard time figuring out each term here, plus you're going to have to add them. Now there is a formula that does it for you. Alright, now we'll look at that formula. Okay, you got to be with me for this. Okay, you got to pay very close attention, okay, while I derive this formula. Okay, you got to pay very close attention now. My blackboard has become a whiteboard. 1 second please. Okay, now this is how we derive the equation for the sum of terms up to a certain term in a geometric sequence. Alright, so if I were to write the first few terms of a geometric sequence, so I start off with a, and then I'd have AR, and then I'd have AR squared. Okay, and so on and so forth. And I'd, if I wanted the first 10 terms, I would have AR to the power of 9. I wouldn't have AR to the power 10. So if I wanted the first 100 terms, I would have AR to the power 100. No, I wouldn't have AR to the power 100. I would have AR to the power 99, because always 1 minus the term for which you're looking. The power you need to raise is always 1 minus the term for which you're looking. Alright, so let's say that term is called n. Alright, it's not 10, it's not 100, it could be anything it wants it to be. So I call that 10. So it's A R n to the minus 1. So the last term is A times R to the power of n minus 1, and the one before the last term would be A times R n minus 2. Alright, and you have everything else in between. Okay, so let's say you are going to do this manually. So the sum of terms up to the nth term would be this if you wanted to do this manually. Alright, let me write an example below it so that it makes more sense to you. Okay, so the first term is 1, the common ratio is 2, and the terms up to which this sequence go up to is the 11th term. So the 11th term would be A times R to the power of 10. So A is 1, R is 2, 2 to the power of 10, 2 to the power of 10, which is 1024, times 1 is still 1024. Alright, so that's just for you to make this a bit more tangible instead of just looking at symbols. Alright, okay, the next thing that I'm going to do is this. I am going to multiply both sides by R. So I'm going to multiply this symbol here, which stands for the sum of terms up to the nth term, by R, and I'm going to therefore multiply each term here by R. Okay, so my A becomes AR, and my AR becomes AR squared, my AR squared becomes AR cubed, and when you get to the last few terms, alright, this would be, now let me take that out and work it out for you in a separate area. So if I said AR n minus 1, and then I times it by R, now watch what happens. So I have AR, so if I just make these individual powers of R, so that's R to the power minus 1 times R. So this R to the power minus 1 is 1 over R times R. That makes R to the power 0, which is 1. So you're left with ARN. And let's look at what would happen if I multiply this by another R. So that's ARN minus 2 times R. So that's ARN times R minus 2 times R. So here it's R to the power of 1 times R to the power minus 2. When you add the powers, it becomes R to the power minus 1 and R to the power n and A. And again, if you wanted to write this in this form, where you combine the powers, it's n minus 1. So when you multiply ARN minus 1 by R, it becomes AR to the power of n, and ARN minus 2 by R, it becomes ARN minus 1. So basically you add 1 to this index. Alright, so that becomes ARN, and that becomes ARN minus 1. Okay, I'm just going to take off the unnecessary bits here that I just wrote to explain this better. So I'm going to take off this, and I'm also going to take this one off. Alright, I'm going to take this one off. Let's do a quick recap. This symbol